Now coming to the topic, so far we covered types of beams. Myself Dr. K. Viswanath Allamraju, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad, India. So far we covered in the last topics types of beams and types of supports and how the supports are being taken place in practical or real field structures. Today's topic is types of loads in shear force and bending moment diagrams. There are different types of loads. Number 1, point load. Number 2, uniformly distribution load. Number 3, uniformly varying load. These are the main types of loads. But in real field applications, these three loads can be combination of these three loads can be acted on structures. We are going to study step by step what are the loads all about. Here it is uniformly distribution load. This figure shows uniformly distribution load. In uniformly distribution load, here what is happening? A load is spread. A load is spread throughout the span of the beam. A load is spread over the span of the beam completely. But what type of beam here it is? It is a simply supported beam. And what type of supports are being acted? Yes, as we have discussed it before, only one reaction means either it is knife edge support or roller support. That's why only one reaction. Now here, how the UDL, uniformly UDL, shortcut name, UDL means uniformly distribution load. Then what is the meaning uniformly distributed means? If you take it any portion of the beam, that portion is what is the length? Suppose L. Another L you take it. The load is acting on this portion is same as on this portion. So element by element if you divide, the load remains constant throughout the span of the beam for a particular length. Here, what is the symbolism to understand in problems how the UDL is going to designate it or how the UDL uniformly distributed load symbols are. Here, uniformly now I am considering as same simply supported beam. The UDL can be shown either rectangle portion in that arrows are downwards. And what is the unit? How to know, define this? The unit for this is either Newton per meter or Newton per millimeter or kilonewton per meter or kilonewton per millimeter. Generally, books follows either Newton per meter or kilonewton per meter. Now, that means here, that means per meter, suppose the length of the beam, the span of the beam is 3 meters. They will give it as, here this portion is 3 meters, for this length portion is 1 meter. This one they will give it as 10 newtons per meter. This per meter 10 newtons. Suppose if this length span is 2 meters, so 10 newtons per meter, then on total 2 meters, what is the total UDL is acting, total load is acting. This is the UDL means Newton per meter. So if you consider it, in the case of a design portion, what is the Newton per meter? This Newton per meter unit is for stiffness, you may call it as. But here it is 10 newtons per meter length it is acting. Then total 2 meters is a 20 newtons total load. The total load is acting. The total load is acting on that portion is 20 newtons total load, newtons. So that means newtons means it is the total load. So this is the symbolism. And one more thing, the UDL can also shown by another symbol. That symbol is like springs. This is also UDL portion representation. If these type of symbol are there in problems or in sums, definitely we have to understand those are the UDL loads. uniform UDLs, uniformly distributed loads. So practically in simply supported beam or cantilever beam, while solving throughout the span, UDL only can be there or combination of other loads also may be there. Let us see another type of load, that is uniformly varying load. Before going to study this uniformly varying load, we have to understand what is point load. Let us discuss what is a point load here before itself. Now, what is the point load? Point load means, this is the point load means, suppose if we are considering simply supported beam, on the simply supported beam, the point load representation is a downwards direction. This is arrow, vertical arrow downwards direction. This is the point load. These are the point loads. There will be certain portions may be there, certain loads, either it can be a inclination also, angle theta. These are also point loads. Point loads represents or denoted by arrows, arrow marks with vertically downwards, or it can be vertically upwards. These are the point loads acting. What is the unit for this point load? The point load, I am discussing about point load here before going to understand uniformly varying load. So these are the point loads. So how it is acting? It is acting vertically downwards. It is acting vertically downwards. Then what type of force it is caused? It is causing on the beam. That force is either the beam can be sheared off, or the beam can also bend in sagging direction. Sagging. This is the word sagging. This is like a sagging word. Suppose the sagging deformation we can observe practically in day-to-day life also. There is, suppose there will be a two poles are there for clothing, no, for drying the cloths. There will be two poles. Two poles are tied or by one rope. If you keep the cloths on that, these are the cloths, then what happens? This rope will deform or deflect in this direction, sagging. Similarly, when the structure is supported by two supports, when the load acts on that structure, there will be micro level of deflection being takes place. That's called sagging formation. Okay, that's called bending movement. You'll see it. Now here, the shear force, this point load, this load is acting in two things. One is shearing, cutting. Why it is shear force? It is acting parallel to the cross section. It is acting parallel to the cross section of the portion of the beam. This is the parallel cross section. That's why it is a shearing, shear force, scissors. Now coming to uniformly varying load. In this uniformly varying load, another name is called triangular type of load. What type of triangle? It can become a right angle triangle or isosceles triangle. So this uniformly varying load, a load is spread over the length of the beam, It is the maximum intensity at this portion. It is spreading maximum intensity varies uniformly on each unit called uniformly varying load. It is the maximum here and it is zero here. It is denoted by symbol triangles with point load symbols. Uniformly varying load, variation. So this is the uniformly varying load. Here the load is at zero at this point, at one end. Load is zero at one end. At this point it is 1 and increases linearly or uniformly to the other end is also known as triangular load. Here you can see it is a triangular symbol. Uniformly varying load or triangular load. So let us summarize what are the types of loads are about. Number 1, point load. Number 2, uniformly distribution load, or in short form UDL. The unit of UDL is Newton per meter. Next, uniformly varying load. Uniformly varying load, also known as triangular load. It will vary Whereas in the case of uniformly distribution load, the name itself defines the meaning, what type of load it is. In the case of uniformly distribution load, the load is distributed uniformly throughout the span of the beam. It can be either cantilever beam or simply supported beam or overhanging beam or fixed beam. But the load, uniformly distribution load, is shown as a symbol is called rectangle. Symbol is rectangle or spring, circular spring, helical spring. We are going to place on that. That is the symbol designation. Okay, we can easily identify load, UDL. Whereas in the case of uniformly varying load, it is varying uniformly from 0 to maximum. Here we are considering in this figure uniformly varying load. Suppose you are taking as cantilever beam. So throughout the span, uniformly varying load is acting throughout the length or throughout the span of the beam. So how it is taking place? Here at 0 at a free end. In the case of cantilever beam, it is a free end and another one is called fixed end. So it is a free at 0 and it is gradually changing, uniformly varying to fixed end is the maximum here. That's why the symbol, it seems like a triangle, right angle triangle. That's why it's known as triangular load. Let us go for further discussion. How can we see practically these types of beams are being taken place, are being observed outside the world, in the real world and real fields? This is here in this figure you can see. You can see in this figure is the central place where is the cantilever beam. It is the cantilever beam supported by traffic lights. There are 3 traffic lights are there. So how can we assume this traffic lights weight? This traffic lights weight is assumed as point loads, vertically downwards taking place. That means how many loads are being acted here? There are 3 loads are acting on this, 3 point loads. At a span, this is the span of the beam, the cantilever beam. So this is what we have to calculate. What is the shear force is taking place? Is suppose it's point A, is point B and point C. At point C, what is shear force? At point B, what is the shear force? At point E, what is the shear force? The shear force variation in this beam and drawing in a diagram, in a relative diagram, in a freehand sketch diagram, then it is called known as a shear force diagram. And also these point loads causes to give bending moment also on this beam, on the span. Then the diagram is called drawing the diagram with the bending moment values. Then it's called bending moment diagram. Okay, let us see. This is the what light, street lights. So here next one we can see it as further session. You can see it in this portion. Where is the cantilever beam? Yeah, you can see it here or here. This is the big billboard. This big billboard is supported by what? Completely by cantilever beam. Okay, this big billboard is supported by cantilever beam, the column. So you can see it here. And what is the load is acting on this cantilever beam? This big billboard, there are 3 types of loads we studied. Point loads, UDL and UVL. So here, what type of load? Is this point load? Or is this UDL? Or is this UVL? What type of load it is? It is considered as uniformly distributed throughout. That's why we will for calculation of SMD, BMD of this real field cantilever problem, we have to assume this billboard load is as UDL, uniformly distributed load. So this problem is a cantilever beam with uniformly distributed load problem. Okay, next. This is what type of beam? This is also cantilever beam. How it is being supported by? These are the sheds. Okay, how it is. These are the difference supported by. This is the cantilever beams. This is the beam 1, There are very different beams are there. These are all our beams, cantilever beams. This is the slab is over on these beams throughout. So how to calculate shear force and bending moment values for this type of case study? Yes, this type of case study, this is, we have to assume it as again UDL loads on these beams. Thus we will find out cantilever beam. What is the real field? Cantilever application are examples in real field, real life applications. Now, and coming to here, simply supported beam. In the case of simply supported beam, yes, you can see here, simply supported beams. This is simply supports. In the case of bridges, you can see here, simply supported beam. Next, in this example, further examples of simply supported beam with examples. Here you can see simply supported beam with examples. This is one beam supported here. If we consider only this span from this support to this support, then what we will call it as, it is a simply support. So further if we extend it up to here, if we consider from this portion to this portion, then we will call it as what? Overhanging beam. Overhanging beam. But whereas this length is a simply supported beam. Now if we consider make it pieces as this portion to this portion only, is like what? What type of beam? Is a cantilever beam, CLB, cantilever beam. So in the case if you want to study the construction of bridges, then completely all these supports, if you consider this called continuous beam, CB, continuous beams. So this is the example for if we consider between two pillars supported by either hinged support or roller support or knife edge support, then that type of beam is called as simply supported beam. Now here it is near swimming pools, you can see people will jump from here. People will jump, they will sleep here, they will stand here and they will jump into the water, the person, okay, or some people will sleep lying down, but the structure, this is related to overhanging beam. This is the overhanging beam that is extended. It is extended from right towards the right direction, certain span, then it comes under overhanging beam. So how to find out these reactions are? We will study always two-dimensional, but whereas real field problems are three-dimensional problems. But in our academic, theoretically, we'll study only two-dimensional problems. Now, further explanation I want to tell you. Suppose further explanation how the real field applications, for solving or for calculating the shear force and bending moment calculations. Suppose if the person is sitting on a chair, what type of load we have to consider it all? Whether it is point load or UDL or UVL. If the person is sleeping on the bed, what type of load is acting on the bed? What is the structure? Why we have to calculate? What is the importance of the shear force and bending moments diagrams? In order to design optimized structure or optimized body, we need this type of these calculations, shear force and bending moment calculations. Thank you for today's session.
Like, share and subscribe. Hit the bell icon for more updates.